Welcome to Study Loop.
So in this problem, first you have to find out the number of moles of the sodium hydroxide which is needed to neutralize the sample of the weak acid. We can do that by just multiplying the volume and the molarity of the sodium hydroxide. And from the number of moles, we can find the number of moles of the weak acid. And from the number of moles of the weak acid and the mass of the weak acid, we can find the molar mass of the acid. Then the second part, we have to find out the molecular formula. And to do that, what we have to do first is we have to consider each percentage mass as a mass by gram. And then we have to find out the number of moles of each entity here, hydrogen, carbon, and oxygen. Then we have to divide each number of moles by the smallest number of moles to get a simplest whole number ratio of the number of moles. And from that simplest whole number ratio, we can find the empirical formula of the weak acid, and then utilizing the molar mass and the empirical formula mass, we can find out the molecular formula of the acid. So first we have to find out the molar mass of the acid, and we will do that by starting or finding out the number of moles of the sodium hydroxide from here. So the number of moles of sodium hydroxide will be its molarity times volume, and which will be 0.1008 molar or mole per liter times the volume, which is 15 milliliter or 15 times 10 to the power minus 3 liter. And this will give us a value of 1.51 times 10 to the power minus 3 mole. So this is the number of mole of sodium hydroxide which is used for the neutralization of the acid. Now we are said that the acid is a monoprotic acid, and since sodium hydroxide contains one hydroxide group, that means so 1 mole of sodium hydroxide will be needed to neutralize 1 mole of a monoprotic acid. That means this much mole of sodium hydroxide will be needed to neutralize the same number of mole of a monoprotic acid. That means the number of moles of the weak acid is same as this. So we can write down number of moles of the weak acid as same as 1.51 times 10 to the power minus 3 mole. Now we know that number of moles, we can write number of moles as the mass over its molar mass. That means we can write molar mass is equal to mass over number of moles. And since we are given the mass of the weak acid, which is 0.2053 gram, over we have um, calculated the number of moles, which is 1.51 times 10 to the power minus 3 mole. So from here we can find the molar mass of the weak acid, which will be equal to 136.87 gram per mole. So this is the molar mass of the weak acid we are asked for in part A of this question. Now in part B, what we'll do is first we have to consider each percent mass as mass in gram, and we will divide each mass by their molar masses to find out the number of moles of each entity here. So what we'll do now is first we'll find out the number of mole of hydrogen, considering the percent mass of hydrogen as its mass in gram. So it will be 5.89 gram over the molar mass of hydrogen, which is 1.008 gram per mole, and this will give us a value of 5.84 mole. Then we'll find out the number of mole of carbon. So the mass of carbon is given as 70.6%. So we'll take it as 70.6 gram over the molar mass of carbon, which is 12.01 gram per mole. And this will give us a value of 5.88 mole. And then finally, we'll find out the number of moles of oxygen, which will be equal to, so the mass of oxygen is given as 23.5%, so we'll consider it as 23.5 gram over the molar mass of oxygen, which is 16 gram per mole. So from here we can find out the number of mole as 1.47 mole. So this way we can find out the number of mole of each hydrogen, carbon, and oxygen. And then, so now we have to do is we have to divide each number of mole by the smallest number of mole to get the simplest whole number ratio of the moles. And here the smallest number is this, so we will divide each number of moles by this number of mole to get the simplest whole number ratio. So the simplest whole number ratio for hydrogen will be the number of mole of hydrogen 5.84 over the smallest number of mole 1.47 mole, and this will give us a value of uh, 3.97. And since we need a simplest whole number ratio, and since it is close to 4, we can write it as 4.0. Then for carbon it will be 5.88 mole over 1.47 mole, and this will give us a value of 4. And for oxygen, since it is 1.47 over 1.47, this will give us a value of 1. That means the simplest whole number ratio here is 4 is to 4 is to 1. That means the empirical formula for this weak acid will be uh, H4C4O. So this is the empirical formula, and from here you can find out the molecular formula just by putting a bracket over it and putting a N here. Now we have to find out the value of N, and the value of N is equal to molecular formula weight of the acid over its empirical formula weight. So the molecular formula weight is equivalent to the molar mass, which we have already calculated as 136.87 gram per mole. Now we have to find out the empirical formula weight, which you can find out from the empirical formula. And if we just add up the atomic molar mass of each atom present here, so we have 4 hydrogen. So okay, we can just do it by, so the empirical formula weight will be 4 times 1.008 for hydrogen plus 4 times 12.01 for carbon, plus we have 1 oxygen, that means it will be 16, and total is the gram per mole. So it will be equal to, it will give us a value of 68.04 gram per mole. So this is the empirical formula weight or empirical molar mass for the weak acid. So we can just put it here, 68.04 gram per mole, and this will give us a value of approximately 2. So the value of N is 2. That means we can just replace this here for N to write down H4C4O over 2, which will give us H8C8O2. And this is the molecular formula of the weak acid given.